I'm happy to see so many people joining here for this year's, or the first virtual TechCon that we're actually doing. Today, I'll talk a bit about what we're doing for the next versions of our main product of Qt, what we're doing to lay the foundations for the future. And this is mainly about two versions of Qt, Qt 5.15, that's coming up very, very soon now, and Qt 6. And I'll lead you a little bit through what's happening in there, what are the new features that we're doing, what are the main focus areas for Qt 6, all of that. I hope I'll have time for some questions and answers at the end, but for now, let me just go through the presentation. Let's start off with Qt 5.15. 5.15 is now the next upcoming release. We have released the second release candidate of 5.15 today. And I'll walk you a little bit through some of the new things that are happening. And there's some of the things that are coming with 5.15. 5.15 is the version of Qt 5 that brings the 5 series to an end. It's the last planned release of Qt 5. And that's that a little bit of a special release, and we've been doing some work there that's maybe a bit different than what we've been doing for other releases. Because Qt 5.15 is there also to help us pave the road towards Qt 6. We want to make sure that the transition from Qt 5 to Qt 6 gets as easy as possible for you. And to do that, 5.15 is also there to help prepare for that. We're doing that basically by helping you flagging certain things and introduce some functionality of Qt 6 already early. We are, as I said, as the first thing, flagging deprecated functionality. This is really important so that it helps you prepare for Qt 6 in your code base. You can see the functionality that is been deprecated and that will get removed in Qt 6. So bringing your application to Qt 5.15, enabling all the warnings for deprecations and then fixing those will bring you a long way towards making your code base ready for the upcoming Qt 6 version. So this is one big thing that we're doing in 5.15, trying to help you there already prepare for what's coming in the future. But we're also doing a couple of other things. We're also adding functionality already here that will become mainstream in Qt 6 and that we're basing Qt 6 on top. The biggest change here is that we're introducing a completely new architecture for our graphics stack, especially on the QML Qt Quick side. That new stack is optional in Qt 5.15, but fully supported, but it'll be always used in Qt 6. So let me walk you through that stack a little bit and show you what's happening in there. In Qt, up to Qt 5.13, 5.14, the default graphics stack in Qt for Qt Quick and QML was based on OpenGL. When we did Qt 5 in 2012, that was our assumption that we could use OpenGL as the one cross-platform graphics API for hardware-accelerated graphics. Over the last years, the world has changed significantly in this area. Not only is the Direct 3D, which we always had on Windows, but other APIs have also made their way in, and Apple is now, it has introduced Metal, has started deprecating OpenGL. On the Linux space and other spaces, there's Vulkan, which has come in, standardized by the Kronos group. And Qt as a cross-platform toolkit, we have the ambition to help you with those kind of different APIs and abstract that away from you. So if an API can't be used fully cross-platform anymore, there's a job that we in Qt need to do. This is what we've done now over the last year. We've been adding a thin layer to abstract away those APIs. Currently used Qt internally. It's called the Qt Rendering Hardware Interface. I'll come back to that one in the next slide a little bit more in detail. The other thing we've been seeing is that on top of that, we have been having Qt Quick as a UI technology, but Qt Quick is a 2D, 2.5D UI technology. And we didn't really have as good support for 3D as we wanted to have, and as integrated as we wanted it to be. So we've been doing quite a lot of work there with what we call Qt Quick 3D, integrating that and giving you a really great tooling also there on the 3D side that combines our QML language, which is really powerful, makes things easy, with full support for 3D. And finally, all the way on the top then, looking at having sure that we have an integrated design studio, which allows you to graphically put scenes together and edit the scenes, edit your user interfaces, and also import from content creation tools such as Blender, Maya, Photoshop, or Sketch. Okay, let's go through things a little bit more piece by piece. We start at the bottom with the rendering hardware interface. As I already mentioned, this is an abstraction layer that we are now introducing for 3D graphics APIs. Initially now for Qt 5 and also the first versions of Qt 6, this is an internal API that we are using, and it's tuned towards the need of Qt. It abstracts graphical objects like materials, meshes, shaders, and other things. And it integrates also with our platform abstraction API, which does the encapsulation with the different windowing systems on the different operating systems that we have. We're adding to that a cross-platform shader module called shader support using the Qt Shader Tools module. This one easily allows you to write a shader for only once and then cross-compile it to all the different graphics APIs, OpenGL, Vulkan, Direct3D, or Metal. We have in Qt 5.15 added that as a fully supported way of doing Qt Quick and the 2D part of Qt Quick. And where it can optionally, with an opt-in, setting an environment variable, replace the OpenGL renderer. And then things will go directly to the native APIs of the operating system. So on Windows, it'll use Direct3D by default, on Mac OS Metal, and on Linux or Android, it can use Vulkan. This is supported in 5.15, as I said, but it will be the default way, actually the only way of doing doing 3D graphics and hardware accelerated graphics in Qt 6. The way we have been supporting 3D content in Qt Quick is now changing significantly with this approach. If you look at our last big release with 5.12, the long-term supported release there, we had basically separate graphic stacks for the 2D user interface using Qt Quick and the 3D Studio and for 3D content using either Qt 3D or Qt 3D Studio. They were living side by side, both on top of OpenGL, but they weren't really integrated, leading to quite a few problems in terms of how do you synchronize the content between the two, how do you do frame-by-frame synchronized animations, how do I basically work between two, and a lot of glue code that was needed to make that happen. In 5.15, we now offer a combined scene graph between 2D and 3D, which we also still base on OpenGL, and where you have your Qt application on top, but you can now use 2D and 3D things together. And this is a little bit how it looks like. I hope you can all read that. With Qt Quick 3D, it's all built on QML as the language, and we have all the language features available. This is a big step forward from the Qt 3D Studio that we had in the past. You get all the great QML language features out of the box, like components. You can easily create reusable components and use them in different parts. You have unified animations and state transitions for both 2D and 3D together. You can combine it with existing Qt Quick APIs with the 2D part, and it's just simply another import. The focus for Qt Quick 3D, though, is to have a high-level API for 3D content, something where we focus on the ease of use, not necessarily on maximum flexibility. For that, Qt 3D is still a great offering that is available and can be used. You can see on the right-hand side a simple, let's say, hello world example where we create a window. We have an image, the Qt logo in this case, 2D, which we animate. Then we add a view 3D with a scene, some lighting, and a camera and a model, which is in this case a cube with a glass material that rotates. It's very easy, and if you know QML, it's actually really easy to understand what's happening there. License-wise, it's available under GPL v3 for our open source users or under commercial license terms for the commercial customers. Qt Quick 3D was already available as a technology preview in Qt 5.14. Since then, quite a bit of things have happened. We've added quite a lot of new features in 5.15. Things like post-processing effects. We have now an API to do custom geometry from C++. Rotations are not, can now be done using a quaternion API instead of Euler angles. We have improved support for 2D elements inside a 3D scene. Things like spotlights now work, and we've done a lot of great performance improvements. On the right-hand side, you can see two screenshots of things rendered using Qt Quick 3D. The upper one is actually a very nice demo that you can even download and test out and try for yourself. Highly recommended. If you want to know more about what's happening in Qt Quick 3D, there's also a talk by Andy Nichols in, I think, 2 or 3 hours from now, which I would recommend. Together with Qt Quick 3D is also the other side of the things, the design and tooling side, and that is Qt Design Studio, where we have been building over the last years a graphical design tools. It's built on Qt Creator and integrates with Qt Creator. You can very easily import their designs from content creation tools and directly test and deploy on your target platform. So it is something that is really targeted and aimed at designers, but it's also available as part of the Qt Creator suite for developers. And with that, we can get a much better workflow between design and development. Designers and developers can work actually on the same code base. It's all based on QML. The QML-based designs that designers create can be directly tested on the target hardware, whether that's a desktop, your mobile phone, or some embedded device. The developers can reuse those designs directly and hook it up to the application logic, to the data, create the data bindings. And with that, you can achieve a much more iterative workflow, something that gives you a much faster turnaround time between design and development. Some of you might have known that we had 2 different tools for 2D and 3D in the past with Qt 3D Studio and Qt Design Studio. What we're doing now is we're unifying those toolings, and Qt Design Studio is that unified shell. So Qt Design Studio with Qt 5.15 is now gaining a lot of capabilities to handle 3D content using QML and Qt Quick 3D. So this is something that that brings all of those pieces together also on the design side, and is a really important also there mark for us to achieve with the Qt 5.15 release. So those were the big items for Qt 5.15, but we've also done still quite a lot of other small things in addition, and also partially also larger things. And I'll walk you through a couple of those. For Qt QML, we've done some work that's also preparing for Qt 6 and also making your life easier. We've added support for required properties. The uppermost example on the right-hand side shows you that as an example where you have a button and you require a property, a description property. This means that whenever you instantiate a button somewhere else, the description has to be provided or you will get an error. This is really helpful to help you require those things. For example, if you need and have to give accessibility support, and then you can require those kind of things to be set by your developers. We have added support for inline components, so you can now put components inline instead of having to put them into a separate file. Like in the second example, where you declare a component labeled image inline, which is basically just setup of two other items, an image and a text item, and defines an API. And then you can use that later on in your QML file, just like it was an external component. A nice new ECMAScript feature was also added with knowledge coalescing, where you can basically, instead of having the ternary question mark colon operator, you just have two question marks. And if the left-hand side is defined, it'll use the left-hand side. If it's null or undefined, it'll use the right-hand side. Then we added more declarative way of registering QML types. And we've done there's a lot of work there has happened with improving linting support with our linter. So you get better warnings there for different things in your code. The linter has a much better understanding of your project's QML code base. And we've added a formatting tool that can automatically format QML files according to our standard coding conventions. We've also done some work to make things QML and Qt Quick as compatible as possible between the standard Qt and Qt for microcontrollers. If you don't know what that is, I'll talk about that a little bit at the end of the talk, so don't worry right now. All of those things are also, a lot of those are there to prepare us also for Qt 6. And there's also a separate talk later today, I think, by Fabian, that will also talk you through more details here. Qt Quick has gained a few new things. We've added a color space property for images, so you can now do color space conversions on the QML side without having to go through C++. You can actually create a path out of text, and that you can use together with the Qt Quick Shapes module. So you can convert the text into a path. This is really convenient if you want to render it at very large sizes, or if you want to apply certain special effects to it, run it through a shader or something like that. For pointer handlers, we now have a cursor shape property, so you can define how the mouse cursor on desktop applications looks like. And we've added a header view to add horizontal or vertical headers to table view. Quite a lot of other improvements in Qt 5.15 have also happened. You see some of them here. We've added a move to trash functionality to Qfile, better integration of Qrunnable and thread pool with standard functions. We've done our usual upgrade of Web Engine to a new version of Chromium. We're now at Chromium AT. Native file dialog support for Android. Qt 3D has gained improved profiling and debugging support. In multimedia, we support rendering now to multiple surfaces. And Qt Network has gained TLS 1.3 session ticket support and configurable timeouts. We've also added support for better custom window decorations. This is a feature that has been asked quite a lot by our users, so that you can put things into the title bar of an application. There's a blog post about it showing you a little bit the details of how that can be done now with Qt 5.15. And then finally, we also have now supporting Qt Lottie fully. Qt Lottie is a renderer for After Effects animations that you can use and integrate into your program. You can see an example underneath showing you one of those animations. So that sums it up a little bit. That's all the cool stuff that's coming in Qt 5.15. As I said, the release candidate 2 has been released today. We do aim of bringing the final release out hopefully next week. That's our goal. It'll be a standard Qt release with a standard 6 months support and long-term supported for our commercial customers for 3 years. Okay, with that, let's move over and have a little bit more of an outlook more into the future and look at Qt 6. What's coming there? Qt 6 is our big new version that's upcoming. We've been preparing and working on that for quite a while now, although efforts have clearly picked up a lot over the last couple of months, and this is our main R&D focus now since around half a year, a little bit more than that. Before I'll go into a little bit into the details of what Qt 6 is all about, what's important when you do a new major version is to take one step back and look at what's important really with that new version. What are the things we should focus on? And to do that, it's important that we also look at the core values of Qt. What's the value proposition for you as a user? What makes Qt a great tool? There's quite a few of them that I think are important. Things like our world-class tools and documentation. It's scalable from very small embedded devices, simple mobile applications to very large desktop and complex desktop applications. We have a huge developer ecosystem. 1.5 million developers out there in the world are using Qt. That's extremely important to us. It's cross-platform, intuitiveness of the API, ease of use, and of course, maintainability, stability, and compatibility. Something that we've been working on all those years is to insulate you from the changes of the underlying platforms. So when we do a new version of Qt, what we need to do there is adjust the product to the new market demands, but keep those values at the heart of what we're doing. The market changes, as I showed you with the new graphics architecture. Things change, like the assumption that we had in 2012 that OpenGL can be used as the cross-platform 3D API are no longer valid these days. So we need to adjust the product to handle those things. And there's other things that are happening. C++ is evolving and those kind of things. And we need to make sure that we adjust Qt so that it stays relevant for the years to come. With that in mind, what are the core themes of Qt 6? Well, the first thing, of course, is to make sure that we also have a good level of compatibility between Qt 5 and Qt 6. We know that there are billions of lines of code written against Qt 5 out there in the world. And bringing those over to Qt 6 is, of course, some effort. And we want to make sure that that effort is as low as possible, that you can easily take your code base and bring it over to Qt 6 with as few workarounds as possible. Actually compile your application against both versions, both Qt 5.50 and 6.0 at the same time with as few workarounds as possible. At the same time, of course, we also need to do some house cleaning. This is important. We've seen that with all the major versions that we've been doing. Over the years, you do accumulate certain things. There are APIs that we think we can do better. We have deprecated certain APIs or functionality. It's been replaced with newer and better solutions. So removing old functionality that has been deprecated is going to happen there. And we are removing all of that, all of the things that have been deprecated in Qt 5. We're removing those for Qt 6. This is why moving to 5.15 as the first step and looking at what's been deprecated is an important step here. We'll also have a somewhat smaller default installation with Qt 6. And as you'll see a little bit later, for 6.0, a slightly smaller scope. A big change that we're also doing is to change on the build system side. As you know, Qt 5 has been using QMake as its internal build system for all the years, and we've been using that actually since Qt 3 times. Now the world has changed, and CMake has become the de facto build system for most C++ based projects. And this is what we're moving to as well. We will make CMake the build system for Qt 6. And this is something that we have come very far with. We've also done a lot of work there to contribute upstream to CMake certain improvements like better iOS support and other things to make sure that it's a great option for you there. QMake support will still be available, and we will support QMake also for the lifetime of Qt 6, but it won't be the default system that we use ourselves for Qt anymore. And we also consider it more or less feature complete. It won't get a whole lot of new functionalities moving forward. Qt 6 will also require C++ 17. When we released Qt 5.0, we were still on C++ 98 as the minimum requirement. With Qt 5.7, we moved to C++ 11. And now with Qt 6, we want to take the next step towards a more modern C++, and use that also internally or inside Qt. Make sure that we have that. So that means we require more modern compilers now moving forward with Qt 6. But it also gives us a lot of more flexibility and options on what we can do internally and what you can do with Qt. A lot of the focus from a now implementation perspective and things that we're changing in Qt is also on the core of the product. We want to have a close look, and we're taking a close look at a lot of our core data structures and containers, core implementations, and look at how we can improve them. So we are rethinking a little bit our containers and doing quite a few changes to those. Many of them having been prepared in Qt 5.15 already. You might not know, but QMap and QMultimap in Qt 5 are actually the same class. QMultimap simply inherits from QMap, but you can actually insert multiple items with the same key into QMap in a hidden way. The same thing for QHash. For Qt 6, we want to make that, cut that away and have a clean split between those two classes. Because this has led to more problems than they are worth it in the past internally, where people suddenly inserted multiple items, they weren't visible, and people were wondering what was happening there. We are doing certain changes, like we're trying to use standard pair now to implement QPair. They have identical functionality. There's no need to have two classes around. And we're trying to see whether we're trying to use standard multimap to implement QMultimap. At the same time, we're also looking into closing the API gaps between the STL and the Qt containers. The STL containers have, with C++ 14, 17, also 11, gained some new functionality, move semantics, ranges, in-place constructions, and a few other things. And we want to make sure that we can support all of that with Qt as well. A lot of it has been there in Qt 5.15 already, but it wasn't 100% through, and we want to make sure that with Qt 6 we have all of those things in place. But we want to keep a Qt style API where we believe is easy to use and consistent there. We are doing, as a second step, a unification of QList and QVector. This is something that has been hanging around for a while. We had those two classes, and they have had mostly the same API, but QList being the class that we have been using all over the place in our APIs. But QList had a couple of performance issues in Qt 5, a couple of things that were a little bit unfortunate. With Qt 6, we're bringing them together. We'll have only one class, QVector then being an alias to QList, getting rid of all the performance issues that we had in QList, improving the performance in pretty much all cases. And we can make that more or less 100% source compatible, that change. It also means that you can assign between a QList and a QVector without triggering any copies anymore, which we had to do today. The one source incompatibility is that references to items inside the list are not stable under modification. They used to be stable under modification in some cases in QList, very few cases, actually many of them weren't. But this simplifies our API, and there's one less class to worry about, which I think I'm really happy about. We're also improving, doing further changes to our containers. We're getting rid of the shared null in the container, instead making default constructions of containers much easier and faster, where you basically just initialize them with 0 and a 0 deep private pointer. The one change that might trigger is that the container.data, so QList.data, might return a null pointer. I don't think that's a big problem. It's rarely used in practice. We're also inlining the begin and end pointers for QList, QString, and QByte array, giving us better performance, and especially also helping us support compile time string constants in a much better way than we can do together today with QString literal. We're also aiming at having better compatibility there, and with the view classes. QString view is something that we introduced in, I think, Qt 5.12, and we've been extending on that over the different releases. We're now trying to finalize that and make sure that QString view and QString are compatible in an API sense, so that QString view has all the methods, non-modifying methods of QString. With the changes, we can also then start doing zero copy conversions between QList and QString or QByte array in case the type of the QList is matching. And we're extending those items to allow more than 2 gigabytes of items. So the size will change from an int to a 64-bit integer on 64-bit platforms. QHash has gotten a completely new implementation. It's completely rewritten from scratch, now using open addressing instead of chaining for handling hash table collisions. It has a two-stage table for minimal memory consumption, very fast in inserts, lookups, and deletes. I'll show you some numbers on the next slide. But also there, we separated QHash and QMultihash. We're gaining a lot of performance and memory benefits with this one, but it has a couple of changes in behavior as well. And that the change is that iterators and references to data stored in the hash are not stable under modifications of the hash. So arrays and growing the table under insertion invalidates those iterators and references. But to show you why we're doing this, here's some numbers and some graphs. You can see this is a logarithmic scale in terms of the number of items, where we showed insertion times and a couple of other things. The new QHash is the green line, the old one, the red one, and to give you a comparison, standard unordered map from the STL is the yellow line. What you can see very clearly is that the new QHash is a lot faster under insertion and deletion, as well as iteration, up to a factor of 10 faster, depending on what you're doing. As well as it uses a significantly less memory than the old QHash. We can see that in the bottom right. The lower numbers for Noah number of entries are not quite reliable because of the OS giving us allocating larger chunks there. But if you look at the high numbers, you can see that we're saving there more than 50% of memory for an int64 to int64 hash. That is significant, and it's at the same time a lot faster. So huge improvements there, and I'm really happy that we could do that, and something we couldn't have done in the Qt 5 series. We are also going and finishing certain changes that we started with Qt 5, making sure that we have Unicode throughout. All text handling assumes Unicode. All conversions between constcasta and QString assume UTF-8. This is something that we started for QString in Qt 5, but there have been a couple of places where we assume something else, like Latin 1 or local 8-bit. We want to make sure this is now consistent all over the place. We will also by default assume that source code is encoded in UTF-8 and set corresponding compile flags so that this is perfectly cross-platform. Simple string literals in source code, you don't need any Latin 1 string or Q string literal anymore. You can just simply write them as quoted text, or with if you want to have them in UTF-16 with a little u in front of it. And that simplifies our Q string classes. Want to get rid of Q string ref, Q char ref, do other cleanups there to make things easier for you. I believe this will lead to a large cleanup of code and make things a lot easier to handle moving forward. Doing also changes there in terms of non-Unicode string and text encodings, things like Latin 1, Shift JIS. We're moving those conversions out of Qt core. We had that in Qt text codec there before. Have a new Q string converter class that supports the Unicode encodings, and Latin 1 and Windows locale for backwards compatibility with an easy to use API and better performance. But for most other things, we'll assume UTF-8 when we come to when we need an 8-bit encoding for Q settings, for XML, HTML, and also for Q text stream. We're changing Q meta type and Q variant. Those had in the past one handler per shared, a rather ugly way of doing things. We had a handler struct for every library and a chained list of those structs so that we could handle things in Qt GUI and Qt widgets as well. It wasn't really very good. It wasn't very extensible, and we needed to handle user types and built-in types to completely different code paths. So something we didn't really want to have, and that was clearly ripe for a rewrite. We have now in Qt 6 cleaned this up for Q meta type. Q variant is still outstanding, but I hope we can get this done in time as well. Where we now use basically the Q meta type has just a little of different things and different methods that can handle the different types, copy them around and do those kind of things. And we're using then the meta type as an ID in Q variant. The data structures for Q meta type are then generated at compile time, and meta type only holds a pointer to the struct of you can see on the right hand side. This simplifies our handling and improves performance. We're doing some changes to the mock and meta object to make it more directly usable by QML and improve the performance both for QML and C++ applications. Add some missing data, make certain things compile time constant, like the property flags that could before be determined at runtime. That allows quite some optimizations for us. Make resolving of the type information that we need in certain cases, for example, for signal emissions, faster. We don't store them by the type name anymore, but directly store the meta type in the mock generated data. And then we're looking into streamlining and improving the internal data structures there so that we can get the required data faster. Another big change that we're working towards is a new property system. That has been actually implemented now. It's all in the current development snapshots of Qt 6 already. And what we've seen is that the concept of bindings to properties is something that has made QML extremely successful and has been one of the big game changers with QML. What we wanted to do now for Qt 6 is to bring that back also to C++. With an easy to use C++ API and a real property-based syntax. No pseudo properties with foo and get foo anymore. They have built-in support for bindings, so you can simply bind them to a lambda on the C++ side, and we're making them available for all of Qt with an improved backend behind it, which also evaluates the bindings lazily, meaning when you try to read the value of the property, the binding gets re-evaluated if it's dirty. And it's extremely fast and can also lead to a lot less glue code that you have to write when doing C++ applications. an example on the right-hand side where you have an item with 3 properties, a width, height, and a border. And you can see how we set up a bindings there in the constructor where we set the height equals to the width, so it's always rectangular, and the border to a 10% of the width. And whenever you now change the width, height, and border will update themselves automatically behind the scenes. Performance is fantastic. If you look at and compare that, the new binding engine in Qt 6 is almost 10 times as fast as what we had in Qt 5. So all of Qt will benefit from that in a great deal. And there's more, and the lazy binding evaluation will actually give additional improvements on top of those, on top of that. We are also working on solving a couple of issues that we've identified with current QML. It has some memory overhead because the object model is separate from the Qt object model. I talked about the meta object changes before. And because it requires a full JavaScript engine and garbage collector. Performance overhead, the binding propagation is immediate. It's not lazy or synced to the scene graph, and the bytecode in JIT. JIT has some additional overhead there as well. Language problems that we saw with large-scale projects is that it's weakly typed and doesn't have an ideal integration with C++. The QML versioning also doesn't make it that easy, and you don't have encapsulation like private things you can keep private inside QML components. So this is something we aim to fix with Qt 6, where we then introduce strong typing. We support compiling QML to C++ native code. We hope to use the new property system. JavaScript is something that we aim to make optional, so you can write your QML in a way that it doesn't require a JavaScript engine. That you don't need, also that you don't need QML versioning, and this is work that's well ongoing, but we are not sure whether everything will be done for 6.0 or whether there's further work that will happen in subsequent patch level releases. Then I talked a lot about the graphics stack. We are finishing that one off. All of Qt Quick 2D and 3D will in Qt 6 use that rendering hardware interface. So OpenGL will be one among several graphics API that you can choose. We'll have full support for Direct 3D, Metal, and Vulkan in there. We have shader tools for cross-compiling shaders at build time and at runtime. And the OpenGL classes that are currently in Qt GUI will move out into the Qt OpenGL module. With that, we can also clean up things and remove lots of old OpenGL-only code paths. On Qt Quick and Qt Quick and the controls, we're doing a lot of work as well. We're looking for a new styling theming engine to make sure that, to try to make them look native on all platforms. Currently, that's something they don't support, and easy to customize. Also integrate with native dialogues and all of those things of the underlying operating systems. We're also working, and that will take some time, towards a public C++ API for those items and controls. And all of this is work that's ongoing. We're laying the foundations now. It won't be done with Qt 6.0. This is more something that we're aiming at for the longer term. Yes, on the tooling side, we continue with the plans that we have on Qt Creator and Design Studio, build great integrated tools for both designers and developers. With the release of Qt 6, we aim to have full support for Qt 6 in Qt Creator and Design Studio. The Creator and Design Studio themselves will probably in the first version still be built against Qt 5, and we'll move those over to Qt 6 after Qt 6.0 is out. One thing that will happen though is that we will reduce the time, the feature set for 6.0 a little bit. We're working, and the focus of our work has been on the core functionality. We are now, we have all the essential modules supported, Qt Quick 3D supported, and we'll see what else fits into the 6.0 timeframe. But some modules will be left out and get ported later. We've also reduced the set of platforms. We're supporting desktop and mobile. We're supporting embedded Linux, but some of the real-time operating systems will also here follow a little later. Timeline, we are planning to have a structure and platform freeze checkpoint in June, where we determine the set of supported modules and platforms and nail that down. A feature freeze in August. From there on, we will not have new functionality and start locking down the APIs. A beta in September with wider public testing, and then hopefully a final release before the end of the year. This is what we're having, our plans for moving forward. It's quite ambitious, but the team is fully focused on that, and I'm confident we can make a really great Qt 6.0 release happen by the end of the year. So that sums up my talk about Qt 6. Now, before I end and we get over to questions, let me spend 2 minutes on, or 3 minutes on 2 other things. We have 2 other products that we announced and have been working on since last year, and I just wanted to repeat that message for those of you who haven't been at our World Summit last autumn. We have a new product for microcontrollers, MCUs, that we released just before the winter, before Christmas. Version 1.1 is now out. Qt for microcontrollers is a graphics runtime built on the QML language. It's a complete new and re-implementation of QML there for those low-end microcontroller devices. It's tiny, so you can build user interfaces with very little RAM and ROM usage. It's very fast, compiling everything down to C++ and making use of graphics acceleration. And it's easy to use because it's the Qt Quick and QML API with reusable controls. But it's limited to that. It doesn't have all the other C++ API that we have in full Qt. But you can, if you're interested, have a look at some of the demos. I think that we also have a talk about that later on. You can really get fantastic results on a very low-end hardware like this Renesas RH850 demo running with 300 kilobytes of RAM and ROM. So have a look at that. Have a look at the demo clip maybe. The other new thing that we announced last autumn is the marketplace. The Qt Marketplace as a central rallying point for the Qt ecosystem. It's where developers can meet, where you can publish extensions to Qt and where you can find those as well as a user. This is a platform that we've launched where you can basically publish your content, whether it's free or paid, and others can discover and find it. We have things currently in there like modules for the Qt framework, plugins to creator, tools enhancing the Qt experience. And we'll expand that further on. And it supports, as I said, both free and paid content. There are more than 100 things available right now, and there's new things coming also with 5.15, like extensions from Falgo, from KDE, KDAP, our partner KDAP, FogLogic, Incredible, and more to come. And since a couple of weeks, we also have a nice integration of that one into Qt Creator. So you can do and discover things from the marketplace in Qt Creator. Here's how this looks like. With that, I think I'm through with my presentation. I'd like to thank you very much for listening, and I'm sure there are quite a lot of questions. I can see a lot. I won't be able to answer all of those during the session now, but I'll try to answer some of them. So if you have questions, put them into the Q&A box. I'll go through them and see what I can answer. First question, is RHI enabled by default in 5.15? Quick answer, no, it's off by default. You can enable it setting an environment variable. Then there's somebody asking whether he could record the meeting. Well, it is being recorded, and you will all get a link to the recording later on. with the new rendering hardware interface, will you still provide options for OpenGL quad buffer stereo? I think you're better off asking that question, Andy Nichols, that question in 2 hours. He's probably the better person to answer it. Okay, what else is there? There's some questions about specific bugs. I'm not going to answer those here now. I don't know. I need to look that up. Comment that documentation should get further work. Yes, that's something we are working on very actively. We have a team of 6 people in our documentation team that's not doing nothing else than trying to improve that. Somebody asking for similar things like Q graphics scene that supports dragging in Qt Quick. Well, the items that we have in Qt Quick, you can make those draggable in an easy way. So maybe that's what you're looking for. But Qt Quick is not currently a full replacement for Q Graphics View. Q Graphics View also being aimed at having millions of items in there. That's not what we are optimizing Qt Quick for as a UI technology. We might be looking into something there in the longer term, though. Why is Qt for MCU not integrated into Qt Creator? I thought there was some integration now with a new version of Qt Creator, and we're working on improving on those things as well. What version of CMake is being used for a Qt 6 build system? We're using a relatively recent version. I think 3.1.2 is the minimum requirement, if I remember correct, or it might be even newer. Most likely we will look at also seeing whether we can make that very easy to you, maybe package a version of CMake that works together with Qt in our Qt 6 packages at some point. Let's see. Again, a question around QMake and its lifetime. As said, QMake will be supported at the very minimum for all the lifetime of Qt 6. What we do after that is not yet decided. We will see. That depends really on how much it will be used by them. Where does widgets fit into all of this? Widgets fits into it in the same way as before. It's a great API to do C++ based UIs for the desktop, mainly static user interfaces. We are now working into providing also the styling and theming for Qt Quick, so you can use that in a better way. And as I said, long term, we also want to provide a C++ API for Qt Quick, so you can use the better UI technologies underneath Qt Quick in the long term, where you have a scene graph that uses hardware acceleration, something that we simply can't do with Qt widgets without breaking everything. But Qt widgets will be there, it'll be supported, and we'll continue to do that. Are we going to have issues with an older compiler in C++11 on Qt 6? In a way, yes, we require C++17. So the compiler has to be able to support C++17. Now, fortunately, there are C++17 compatible compilers available pretty much on all platforms. Some of the real-time operating systems are lagging a little bit behind, but they are currently working on C++17 compatible tool chains. Those will come out during this year still, and we will bring them Qt to those platforms again once they are out. Until then, Qt 5.15 is still around and will be available for you, and you can use that. Will Qt 3D still be available under development in Qt 6? Yes, our partner KDAP is actually doing a lot of work on Qt 3D. Big thanks go to them for that work. And they have quite a few plans for Qt 3D and also in Qt 6. Somebody likes all of the stuff that I'm presenting and whether you can have a preview. Yes, of course you can. All the code is out there in the open that we have, all the things that we have been working. We're working on qtproject.org. You can download the development snapshots from codereview.qtproject.org or git.qtproject.org or git.qt.io, where we have mirrors. Just download it, play around with it. We are happy about any feedback we can get. Will the new C++ property system work also in QML for C++ classes that are registered as QML component? Yes, it will. That's our goal. And our goal is also to port all of our Qt Quick items and related classes over to use the new property system because, as I said, it has a better performance than the old one. The old Qt property system will stay around for backwards compatibility, so you don't have to worry about your existing code. Qt for Python, will Qt for Python support embedded platforms? The Qt for Python work is continuing as before. I think on many of the embedded Linux devices, you could also use Qt for Python there if you wanted to. That is certainly possible. Open source status of Qt 6, yes or no, any changes? Qt 6 will be available under open source licensing just as Qt 5. That's the easy answer. I think I'm running out of time now with answering more questions. There's quite a few more in there. I'm sorry I won't be able to answer all of them now. Whether Qt Quick 3D comes fully documented, of course it comes. If we support a module fully, it comes documented and with examples. I think, let's see if there's anything else that is new and that I can easily answer. No, I think I'll leave it at that because the next talk starts in 1 minute from now. I hope you enjoyed the talk and if there are further questions, don't hesitate to contact us, talk to us. Maybe many of them will also get answered during the other sessions that are still coming up in the Tech Summit. Thanks a lot for listening and goodbye.
Thank you all for joining. There's also the opportunity to join the professional services on the live chat on the live event portal. So please don't hesitate to join us there. Thank you all.